Nostalgia is a bit of a funny thing, isn't it? It seems to draw us back to our youth, to make us want to play with the things that we had then and even the things that we couldn't afford. You know, for me, it's this wall of vintage computers because I personally enjoy the hardware side of it. But for Tom, over in County Durham, for him, the one thing that he wanted to do was play his Pokemon GBA cart. This is Pokemon Ruby version, but as some of you may well know, this cartridge would have had a battery in it. Now, that battery was only there for the real-time clock. Why a cartridge needs a real-time clock, I don't know. I don't do a lot of console gaming. But Tom thought he'd have a go at trying to replace the battery in this. And unfortunately, it didn't quite go to plan. As you can see, this looks a bit of a mess, but Tom watches the channel, and so he had asked if I would be able to try and sort this. You can see there that there's quite a bit of solder on this. The battery would have bridged between that point and that. It's sat on top of this IC. I think this one being the game ROM. I think this one is the flash ROM in which the save data is stored. That's what he wants to try and save. You know, that's what he wants to get back to. He has saves on this from his youth. And this one up here being the real-time clock, there is the crystal associated with that. But I think what's happened here is that Tom has tried to replace the battery, but he hasn't used any flux. That's why we have a couple of big blobs of solder. That's why we have a lot of bridged pins just here and here. So I think the first thing we should do is pull out the microscope. We've put a lot of flux on this, and let's try and tidy up the solder just to see how bad the damage is. If in fact there actually is any damage, because it might be okay under this, we don't know. So hopefully you can see now a bit clearer what I'm talking about. We have bridge pins along the side of this flash chip, a load of bridge pins along the side of this ROM, one big nasty blob of solder here. Now it does look like there's a few components missing, but as I understand they may not have been populated in the first place. In fact, the only component that may be in this area is that resistor. Although I'll be honest and say I'm not sure about that capacitor there. So we will need to try and find a bit of a bill of materials, say, for this cart. There actually are replacement PCBs available. You can get them from PCBWay. But I'm not quite ready just to give up on this one yet. In fact, it maybe looks as if there might have been a resistor there as well, an R2. Just basing that on the shape of that solder there. Although, I can't say for sure, you know, it may well be the case that when he was working at these pins, he might have dropped a bit of solder onto those points as well. But yeah, let's see if we can't tidy it up a bit. So, a bit of chip quick to the rescue. And we'll just start on that ROM chip. And let's see what this does. Just trying to use the iron itself to wick up the solder that's there. Maybe needs a bit more flux. That looks a bit better, although maybe a bridge pin there, is it? There, I think that looks good. So what about this mess on the flash IC then? Same thing again. In fact, let's see if we can tackle that big blob where one of the battery terminals would have been. I might need a bit of wick for that. I am running dangerously low of this stuff. This roll is almost done. Well, it's not expensive, so I will get some more. I've moved that cap. In fact, let me see if we can just take that cap off the board before we lose it, because it is tiny. has dealt with that. Although the flux that I put down there and then the flux that's built into our braid here, it's just burnt on the board there slightly. So I'm just going to clean things just to see where we stand. And you know what? I think this PCB is fine. I don't actually see any damage on it. Right, let's see if we can tidy up those pins now. So I'm just going to spin this around, make it easier for me since I'm left-handed. Lots of flux. And let's see what we can do. Finer pitch on these pins here, so it is sort of harder just to get that solder away from them. What I might be better doing here is using a wee bit of braid just to try and mop that up. I got this slightly thinner stuff, 1mm braid. It might be better for this sort of thing. Yeah, I think I dealt with most of it. Then what's left there, we'll just try and spread out among the pins that are left. I think that's looking pretty good. So we'll go back to the ROM chip. Just want to finish reflowing this side of it here. And then the other wee bit just on the other side of this ROM chip. You tidy up where that other pad was for the battery. And again, I'm just going to reflow that chip. I've knocked a component and knocked a capacitor there. Didn't even see it. Wasn't paying enough attention. I was more closely watching the pins on the chip. That must be a negative side because it's actually quite hard to melt the solder on that. It's obviously just connecting to the large ground plane here beside it. In fact, yeah, it is negative. You can see the symbol there. Okay, so again, just let me try and tidy things up. In fact, let me just remove that capacitor there. And we'll refit that along with that other resistor in a minute. I'm not going to put this in the ultrasonic just because of the crystal there. Ultrasonics can kill those things. So we'll try and clean this with the cotton buds. And I suppose since we've reflowed more or less everything on this, let's just reflow this side of the flash ROM. I just want to touch up around that resistor as well. This looks a little bit crusty. You know, one thing I probably should have done here at the start was put a bit of cotton tape over the gold-plated connectors there. Don't want to get any solder on those. Just going to reflow around that other resistor there, R7. I say try and reflow around it to wind up moving it. Well, it's not back in the position. There, I think that's okay. So we need to put R9 back on, but because this is so small, I think I'm going to try and do this a little different. I'm going to try and put this on with a bit of hot air with the tweezers. First of all though, we'll get a bit of flux down. And we'll tin up those pads nicely. A nice wee blob of solder on them. Then we'll take the hot air gun with a low air speed. Just hold it on here until that solder goes molten. Then we'll set the component on. Not quite molten yet. Yeah, that didn't really work, did it? I've actually just built another board using, granted, bigger surface mount components, 0805s. I think these are 0402. but I used that method to fit everything, and I fitted all the surface mount components, you know, in like 15 minutes. But it just didn't really work there. So I suppose we'll just do it the old-fashioned way. And then we need to refit that capacitor as well. Not happy with how R7 looks there. In fact, I'm not even convinced that that is making good contact there on the right hand side. Let's lift it off the board quickly just to try and tidy that up a wee bit. There's just a bit of burnt flux in there, which was making it rather untidy looking, I think. There, I think that looks a bit better. Right, let's put that other capacitor back on before we forget about it. C2, looks like it's maybe a decoupling cap, just for that ROM chip. There, that looks pretty good. Just noticed a couple of bridge pins when I reflowed this side. You can't really see it here. Oh no, maybe you can. Just there. There's a bridge pin. And now there's even more bridge pins. I'm just going to tidy things up a bit here, and then we'll put the battery on. Cleaned up pretty well, but before we fit the new battery, I just want to check that we're not missing any components. So over on PCBWay, in their shared project section, this is the project for the replacement PCB. I don't think we need a replacement PCB. I think this one's okay. But if we scroll down through this, there is a very handy bill of materials there, and even a picture of one of these PCBs fully populated, although it's got a different flash chip on it. Now, looks like we're missing a component there, which I thought was R2, but it's not. That's actually C1, and we're missing C3 as well. If we go to that bill of materials, they are both 100 nanofarad ceramics, so they're probably just decoupling caps. It most likely will work without them, but I do have some, so let's just try and fit them. And as I thought, yeah, it's all 04, 02 stuff. Tiny. Probably should get the microscope back out to do this, but we'll just see how we get on here. There, I think we got that okay. So it's just a matter of fitting the battery. Now the original one did come with it. It is very dead, 0.03 volts or something like that. Not surprising, because I think that might be a date code on the back of it there. But you can still get them handily enough. I ordered a set of them from Amazon. This side of the battery being the positive side, so it's going to go on like that. And I just need to bend those legs down to meet those pads. I think that's it. No, it's not. No, it's not. I didn't notice this. Oh no! I need to take that battery back off. Certainly just the positive side of it, because the pad is lifted. Positive pad is lifted. Did I just do that? I don't think so. But maybe I did. Maybe I did do that. If you look at the picture of the PCB again, on PCBWay, the populated one, there's a trace from this bottom left corner that goes to a via, just beside R7. Looks like I am going to have to get the microscope back out, because I think we now need to run a patch wire. I swear you couldn't make this up, but the Andon Star microscope, its HDMI output just broke. It's a mini HDMI port, and yeah, it just broke. But anyway, hopefully you can make out what's happening here just from the camera recording this screen. So you can quite clearly see that this has lifted. You can see like a gap around the back of it there, and on this side. Still attached to the trace here, which goes to position R9, and it comes down here to this via. Might be a bit of a blessing this, because that does look a little bit crusty. So I think what we're going to have to do here is just try and scratch off some solder mask at this via. Don't think we're quite there just yet. In fact, I'm sort of wondering if that via is damaged. I mean, there's no sign of any battery leakage or anything on this, but I don't see any copper coming through there. What I might need to try and do is drill that via out, because it does look a bit blocked there. Put a wire through and make it off on the bottom side somewhere. Or I wonder, could we just get a wire through it as it is? Let's see. Yeah, we're through. Let's leave that on this side with plenty of length on it. Come back to that. Ooh. Ooh. There's another damaged via there. Look at that. Which I suppose is why you can get replacement PCBs. That is definitely damaged. That will need to be repaired. Or so I thought, because we skipped forward a few days here. You can see that I have now patched that trace down through that via to the other side of the board, and you can see that there's quite a few vias here that have now been plugged. I flowed solder into them. That's because all of those are sort of black. So it must be the case that the old battery that was on here, this thing, it must have caused some amount of corrosion on this board, and that probably explains why you can get replacement PCBs. Although I'll be honest with you, I didn't think these type of batteries ever really leaked. You can, however, see some tarnishing anyway, just around that seam of the battery there. So I can only assume it had done some amount of damage to the PCB here. In terms of that other hole that I thought was a via, no, it's just a hole. There it is there. It goes down through the PCB and cuts those traces. There's actually a couple of them on the board, another one there and there. So it must be the case that this PCB, the Nintendo AGB-E05-01, it must be used in various different cartridges, presumably with different components on here, which require different layouts of the traces. In fact, the one trace that I repaired coming off the bottom of this battery down through that via to that point there, it runs up to there, so it's cut, and on this side it runs back just to a test point. So it isn't actually needed on this side of the board, although the repair there will give a little bit of structure just to that pad, which is definitely still floating, but it's connected at that side now, and it is still connected to that resistor. That resistor, which you probably noticed I managed to knock off along the way, so I had to go and order some more. That's why we're a few days later. One thing I want to try and do here, just to try and give that some rigidity, just because it is floating about there, and yeah, it is being held on two sides, but I don't really like the fact that I can flex it. So I'm going to put a lot of solder mask on that to try and help hold it in place. And I'll just be lazy and stick it on with the edge of the tweezers. Try and get it right around that solder blob. It is going to make it more difficult should anyone try to replace the battery again in the future, but I mean, the battery should last for multiple years. But as I said, when this goes off, it'll just help hold everything in place there, just with that pad now being broken. Okay, it might look a bit glossy. That's just the way that solder mask is, but it has now hardened and there's no more movement in that. So last thing to do is just reassemble. There's a little bit of damage to the back bit of the case here. There's nothing I can do about that, unfortunately. Not quite sure what would have happened to it. But we'll see if we can get it back together anyway. And the way these go together is that just there and there's a notch in the case which lines up with those two tabs either side, sort of in the middle of this. So you put it together like that and then slide the top cover up in, and that's it. Just a tri-wing screw then holds everything together. But does it work? So this is my Game Boy Advance. Can't remember where I got this. I think it might have been a local charity shop find. It is missing the battery compartment door, but otherwise works fine. But what about our game? Does it work? That's not a good sign. I think it's supposed to say Nintendo along the bottom there if the cartridge is loading. Just give me one of my cartridges. This is Rayman. Yeah, see the way it says Nintendo there? That's what we're supposed to see, and there's the game. So possibly still a problem in here, although I think what we should maybe do is just clean the gold contacts. And we'll just do that with a bit of IPA on cotton bud. Yeah, it is quite clean actually. Yeah, there's not really anything coming off that. Maybe just hit this thing with a blast of contact cleaner. Let's see what that does. Nintendo. Yeah, it's working. Pokemon Ruby version. Yep, that's right. So, is the save there? That's the thing that Tom really wants. You know, that's why he wanted me to try and get this working again for him. Is his save still here? Yep, there it is. Player Tom, time 13 hours, 54 minutes is that. He has 5 badges and 39 Pokédex. I don't do Pokemon, I don't know. Does that mean he's collected 39 of them? But in any case, that does seem to be it fixed. Well, there we are, just a quick video, just a simple repair. But as we said at the start of this, nostalgia is something that's slightly different for everybody. And for Tom, he can now continue his trip down memory lane by playing Pokemon Ruby version on his Game Boy Advance. So I'll give this back to Alan, his uncle. He can pass it on to him. And yeah, thanks for watching, and I'll see you next time.